side one is 2 centimeters, this is 7 centimeters, 12 centimeters, this is 5 centimeters, this is 3 centimeters. So like always, because this video is there's a bunch of ways to do this. The way I like to do this is to break it up into two rectangular prisms. And the ones that jump out at me is one prism like this that is 3 centimeters wide, 5 centimeters high, and then it is 7 centimeters long or 7 centimeters deep. So this one right over here. And if this part right over here was transparent, you would see it. You would see it look just like this. You would see it look just like this. And so this one, once again, it is 3 centimeters wide, 7 centimeters long, 7 centimeters long. So this distance right over here is going to be the same as this distance right over here. So 7 centimeters long. So the width times the length times the height, it's 5 centimeters. Gets us to, let's see, 3 times 7 is 21, times 5 is equal to 20 times 5 is 100, 1 times 5 is 5, so it's going to be 105. We could say 105 cubic centimeters, because you have centimeters times centimeters times centimeters. So this blue part right over here, this blue rectangular prism, has a volume of 105 cubic centimeters. So now we can separately figure out the volume of what I am now highlighting in this magenta color. What I'm highlighting in this magenta color. If this was transparent, you would see this part back over here, right over here. So what are its dimensions? Well, we know its height is 2 centimeters. We know that this dimension right over here, I guess we could say its depth, we could call it that, is 7 centimeters. But what is this right over here? If we want to consider this, maybe its length, or maybe its width, depending on what we want to call it. Well, let's see, this whole thing is 12 centimeters. From here to here is 12 centimeters. And we know that from here to here is 3 centimeters. So this piece right over here, this piece over here must be 9 centimeters. So that must be 9 centimeters is this distance right over here. So the volume of this magenta part is going to be 9 centimeters times 7 centimeters times the height times 2 centimeters, which is going to get us, let's see, 9 times 7 is 63. 63 times 2 is equal to, 60 times 2 is 120, 3 times 2 is 6, so it's 126 cubic centimeters. So the total volume of the entire thing is going to be the volume of the magenta stuff, which is 126 cubic centimeters, plus the volume of the blue stuff, plus 105 cubic centimeters. And that's going to give us, for the entire figure, 6 plus 5 is 11, so 1 plus 2 is 3, actually 110 plus 210 is 3 tens, and then 100 plus 100 is 200. So we get 231 cubic centimeters is the volume of the entire thing. Fascinating. So 7 feet high, 4 feet long, and 8 feet wide is sitting at the water tank is 12 feet high, 5 feet long, and 9 feet wide. A solid metal box, which is 7 feet high, 4 feet long, and 8 feet wide, is sitting at the bottom of the tank. The tank is filled with water. What is the volume of the water in the tank? So let's think about this. We have a water tank. It's 12 feet high. I'll try to draw this as good as I can. So it's 12 feet high. It's 5 feet long. This looks like that's about 5 feet. And it's 9 feet wide. So this is my best rendition of what the tank looks like. So the tank might look something like this. That is my water tank. Let me draw it, draw the whole thing. So there's my water tank. And I'm going to make it transparent so that we can see what's going on inside of the tank. So here we go. There's like a helicopter outside or something. I don't know if y'all hear that. But let's see. So there is my water tank. 12 feet high, 5 feet long, and 9 feet wide, 9 foot wide. And then they say there's a solid metal box which is 7 feet high, 4 feet long, and 8 feet wide, sitting at the bottom. So let's see if I can draw that. So it's 4 feet wide, 4 feet, or I guess we could say 4 feet long, 7 feet high. So see, 4 feet might look something like this. It's 7 feet high, which might look something like that. 7 feet high. Obviously, I'm not drawing it perfectly to scale. 7 feet high and 8 feet wide. So it might look something like this as it's sitting in this tank. So this is that metal box. And they say it's a solid metal box. It's not like any water can fit in here. So let me make it as a solid metal box. So this is a solid metal box. And then I'm going to fill the whole thing. With water. I'm going to pour water into this thing. And the water is going to start filling up. And it's going to fill up all the volume of the tank except where the metal box is. It's not going to be able to fill in that volume because the metal box is solid. So it's going to fill up. We're going to slowly fill this thing up around the metal box. So what's the volume that's going to fill up? Well, it's going to fill up the volume of the tank minus the volume of the metal box. It couldn't fill in the metal box volume. So let's figure out what that is. The volume of the tank is going to be 9 foot by 5 foot times 12 feet. That's the volume of the tank. Tank volume. And from that, we want to subtract the metal box volume. So minus 4 foot by 8 feet by 8 feet. 8 feet by 7 feet by 7 feet by 7 feet. This is 4 feet wide. It is 8 feet. What are they? They say it's 7 feet high. 7 feet high. It's 4 feet long and it's 8 feet wide. 8 feet wide. So this right over here is the volume. This is the, I guess we could call it the metal box volume. The box volume. And so what's in between, or when you take the tank volume, subtract out the box volume, that's how much the water can actually fill in. So I only do the water partially filled, but once it's already filled in, the water's going to go all the way to the top here, and it will fill in everything except for where that blue box is. So let's figure out what this value is. So 5 times 12 is 60. 60 times 9 is 540. And then in blue here, let's see, 4 times 8 is 32. 32 times 7 is 210 plus 14, which is 224. So it's minus 224. Minus 224. Did I do that right? I don't want to make a careless mistake. So 32 times 7. 2 times 7 is 14. 3, which is really a 30 here. 30 times 7 is